Good afternoon, everyone. So I'm going to talk about generation and visualization of test cases for multi-core and multi-threaded environments. So all designs have been moving towards a SOC. Mark talked about reducing design effort and increasing verification effort. And since morning, you've been hearing that the designs are moving towards a SOC-based environment. The reasons are most of the IPs are built and you kind of integrate them and ship them. So today you use a UVM environment to do a full SOC verification typically. So you have other means of doing it. So for a full chip simulation, the runs are too slow because your simulation time is going to be huge because of the test being long. Too hard to develop all the sequencing that you need. And you don't have a good link between your embedded environment and your verification environment. So what happens is typically the SOC teams end up just doing a stitch and ship. You take all the IP, then run a couple of tests, which is register test, connectivity test, and you're done. Hoping that all your IPs have been verified and all of them will work together without any problem. So the verification limitations are, again, it's pretty hard to write embedded C tests for, to start with for even single core environments. But when you're talking about multi-core environments, it gets really tough because trying to understand various application scenarios and to build a test case, even a simple test case, is going to be really difficult. And they're very difficult to maintain and to extend. So today you can build one, but tomorrow if you extend or increase the number of cores, then it's going to be difficult to extend the same test case to match your further requirements. And then you have some teams who extensively rely on emulation and prototyping, but then the cost of spending or running tests on emulation and prototyping and trying to debug them becomes more because your visibility is very less in a emulation or prototyping environment, and trying to link all your simulation embedded software tools together is a pain. And then if you still say, okay, I've run some scenarios, let me move on to a chip, then you end up finding bugs in your post-simulation or in your silicon, which is very costly. So today the SOC verification is you're just trying to address the tip of the iceberg. You know the iceberg story that only very little is seen outside. Most of it is below the sea, right? So similarly, you just do the stitch and ship process, which is just you run connectivity test, IP integration test, and then you say, okay, I'm good enough to tape out. But then there are so many other scenarios here, which are typically use cases, concurrency, coherency, system power, and performance verification. You don't usually try to run these because it's too complex to build these. So let's take a typical example here, a digital camera, where you may have a single or multi-core, multiple memories, image processor, you have a fabric, and then you have all these other things. And you have a test bench sitting around it. This is your SOC, and you have the test bench. Typically, what you do is you develop manual test cases. You go through the spec, you have a bunch of engineers building their C test cases. Then you put it through the compiler, load it into your memory, and let it run. But then it is always better. Here you have a lot of limitations. One is having you are not typically not able to generate a lot of test cases. You generate only for these two, right? And you don't run too many system level scenarios which are required for a SOC. So it's better to generate test cases automatically, and typically so for multi-threaded and multi-processor situations, which is today's SOCs are mostly multi-processor, multi-threaded environments. And you would like them to run on the embedded processor, and you would like to stress the design. And it is always good to generate the test cases from a system scenario model rather than trying to read a spec, bring out all the various crosses or application scenarios and then write a test. So what BREKER does is it has a graph-based format for capturing the SOC data flow, and you can actually reuse all the graphs that you have generated at the IP level. So you can essentially generate IP level graphs and reuse them, and you just need to constrain your graphs to generate the test. Now, the tool TrekSoC can actually generate tests both at the C level and at the UVM level. So you can, that's how you reuse the graphs which you generate at the IP level. So you have different scenario models for each of the IPs. So you have for the camera, for the SD card, for the other IPs. And then you have a SOC level model which controls these lower level graphs. And then TrekSoC takes this input and generates the C test cases. Now these C test cases are constrained driven test cases, so it can generate different application scenarios very quickly. And they can be involving multiple processors or multiple threads, and they can run, you can have short tests, you can have long tests. All that is controllable from the constraints that the user has control over. And then Trek also talks with your BFMs and with your design. So it has good control over putting into the design and what you're seeing, and it also enables you to do an end-to-end comparison between your C and your system Verilog or UVM or C or MATLAB test case, BFMs. So essentially, when you use Trek's automatic test generation, you kind of address all the different requirements of SOC verification, not just the tip of the iceberg. So coming back to this scenario or the application, typically what you may do is you may want to test a scenario like this where you take data from the BFM, which is an external environment, to the camera and you put it into memory. And then from the image processor to memory, and then you store the information back in your SD card. So this is a typical scenario. So in Trek, what you do is you start from here and you start defining the path. And what would happen is after you've defined all this, the tool would generate a test case which would generate the data from the camera here. And it will take the different paths depending on the constraints that the user provides. And then it generates the different application scenarios. Now, there may be scenarios where there will be power conditions. You may want to switch off a particular power domain, switch on a particular power domain. All that can also be simulated. So typically, this is a complex use case scenario where you have SD card, USB port, and your camera. So the path could be from camera to image processor to your display controller, or USB to image processor to display, or USB directly to your video processor and storing. So these are different scenarios. You see that from this graph, it has really grown to a really complex scenario. Now, for a manual C test case to be generated for a scenario like this, it's going to be really tough, which the tool does automatically for you. So with TrekSoC, you can actually do all of these. You can concurrently schedule all these things in parallel. It will allocate and deallocate memory on the fly. It can handle interrupts, so it can simulate an interrupt handler, interrupt controller. It does I/O management. It enables you to do better debug, and it also enables you to do result checking. So all these Trek services are run with TrekSoC. So this is the latest release from the tool. This is the GUI snapshot where we have two processors running multiple threads, where all the green blocks are completed scenarios, and the blue ones are ones that have been scheduled. So this is a runtime display. It's running 4 threads on CPU 1 and 4 threads on CPU 2. So this is a typical multi-core, multi-threaded environment. So the green driver scenarios are the ones that are completed, and the other ones are waiting for execution. And you can also set breakpoints in your GUI where then it enables you to debug the graph itself. So you can stop and then use a GNU debugger to see where, in which thread the simulation is, and then you can debug using your waveforms and your Trek GUI. So you can see that this is a typical driver scenario, and some threads have already completed, some threads are still waiting. So it could be scheduled on one processor, some threads, and the other processor will have some other thread. So all this is handled by the Trek generation. So tool will generate all these different scenarios. You can have one thread running in the same multiple threads running on the same processor, or multiple threads running on different processors. It supports multiple design levels, so you can use TrekSoC at the SOC level, at the IP level where you don't have the CPU, you just have a BFM for the CPU, or you could use it just at the IP level with only one IP. So for all these, you can use the same graph definition from where you generate the test case. So in summary, your stitch and ship environment does not suffice SOC verification. So TrekSoC automatically generates the C test cases for you to run embedded processors and to also generate deep corner case scenarios. And the scenario models are easy and natural to create, and these are graph-based. They capture the verification knowledge quickly, and it also helps you to communicate with your internal teams effectively. Questions?
Do we have any questions for Nambi before we go to break? There's one at the back.
Hi Nambi, this is Guru Prasad from Sankhya Labs. We had interacted at the stall and I had many doubts cleared there. But one doubt is this TrekSoC generates .c files, and apart from doing that, it also creates some event file or something, if I have understood correctly, and then does the comparison of the expected result and the observed result. So for that, you need to interact with the test bench.
Yes.
So if I have a test bench ready with me already, I have a test bench. So how much effort is required to interface this TrekSoC to that existing test bench?
How much effort is, it's very subjective. One, if you want me to say in time, it could just be a few minutes to 1 or 2 hours to understand your environment and then integrate it. It depends on how your test bench is architected, how we can actually reuse your tasks or functions or whatever calls that we can make to your environment.
Can it be like in a generic sense? Can you answer
that? Can you rephrase your question? I didn't understand. Sorry.
Like, can you give the answer in a generic sense? Suppose, like, so I get the result back from the DUT.
Yeah.
Okay. So generally, I will compare it at the scoreboard. Generally. Yeah. Okay. So using TrekSoC, what happens if I'm using TrekSoC?
Okay. If you're using TrekSoC, you take the data that's coming out of your DUT, and then you call your BFM when you have the data from the DUT, and you kind of compare it at that point of time.
Okay.